Cramer's rule is just another alternate method to solving systems. So other than resorting to using methods such as elimination and substitution, we can use Cramer's rule. So first of all, what we're going to do is set up the system and use matrices to be able to do that. So let's do that. So what you're going to look at first is the coefficients of each one of your variables, which in this case are the ones that I'm highlighting now, and those are going to go in brackets. So -2, +1, +1, and +3 will go in the first pair of brackets. Then we need to multiply that by the coefficients variables x and y, and we will set it equal to our output values of 5 and 7. And if you look at multiplying row by column, so if you look at multiplying this row by this column, you'll notice that as you pair up the -2 times the x plus the 1 times y, you are ending up with what is on that side of the equal sign. So all you did was rewrite them in a setup using matrices. So our goal is to solve for x and y. Well, what you're going to do first is you're going to calculate the determinant. Okay, so the determinant, we're going to use the capital letter D, and you are going to find the determinant of -2, 1, 1, and 3. So basically this one right here that I'm talking about. So the determinant tells us to multiply those two and then subtract it from the product of these two. So showing work, I'm going to write -2 times 3 minus the 1 times the 1, which in this case we end up with a -7. Next, what you're going to do is calculate the determinant with respect to x. And what that means is that you are going to take the answer of 5 and 7, and you are going to move over here and replace this column, the -2 and the 1 column, which are the coefficients of the x's, with 5 and 7. So in essence, the determinant that you are looking for is going to look like this. The 5 and the 7 replace the coefficients of your x, and the y coefficients remain the same. Okay, so 5, 7, 1, 3. So we do the product, 5 times 3 minus the 1 times 7, which is 15 minus 7, and we get an 8. So we're going to do the same thought process, find the determinant with respect to y, but this time we are going to take our output values and we are going to replace the y coefficients. So let's see what that looks like. So we retain the x coefficients, we replace the 1 and the 3 with a 5 and the 7 this time, and we calculate the determinant. -2 times 7 minus the 5 times the -1. So -14 plus 5, -14 plus 5 is going to be what? -14 plus 5, -9? Okay. So far, so good? Okay. So, what else do we do? -2. Oh, wait a minute. I thought I was doing wrong because I was like, I don't remember that being the answer when I practiced. Let me put the right number there. There we go. So, -14 minus 5 is -19. My bad. Okay. So, once you have calculated those determinants, we know by formula that in order to find our x's and our y's, our x coordinate is found by taking the determinant with respect to x and divide it by d. And to find the y coordinate, you take the determinant with respect to y and divide it by d. So we're going to do that. So the determinant with respect to x in this problem was our 8. And we are going to divide it by our d, which is -7. So there is our x coordinate. And then we'll do the same thing for our y. We take the -19 and we divide it by our -7, which we know is just 19/7. And so if you attempt to do this now with elimination or substitution, you should as well get an x and a y of those values.